Hi, my name is Martin. I'm based in Vienna, Austria. Work as a consultant for Tietoevry. You can reach me on these socials. And today I want to talk to you about source generators. So I want to give a bit of an overview over source generation and metaprogramming in .NET. But I also want to show you some features in .NET 6. So source generators have been around for a year and a half about now. So they have been used a bit, but now actually the .NET framework itself has some features that rely on source generation. And maybe that's something that you can actually start using in your projects tomorrow. Also, we will be implementing our own source generator. And I also want to show you some new APIs that Visual Studio just added in Visual Studio 2022 or in Roslyn 4. And of course, some tips and tricks what to do if you actually want to ship a source generator. My motivation for that is, metaprogramming is a very helpful tool. If you find yourself writing a lot of code, then a machine should write that code for you and not you yourself. Also, aspect-oriented programming is something that comes up a lot and is still hard to do in .NET. For me, usually the most useful use cases are serialization. So where I have like new serialization formats, something like ASN1, for example, that is used also in intelligent infrastructure. But of course, now we have things like OpenAPI, where we generate Swagger definitions or OpenAPI definition files and then want to maybe consume them from a C# client or from a TypeScript client. And we want to have generation both for the specification, but also for the client code. So that's also where it's been used from the beginning, for example, for XML serialization. In .NET, there are a few different options for doing metaprogramming. I think the most classic one is reflection. So I think we've all been using reflection at some point or another. Also, a lot of libraries are based around reflection. And usually then when we use reflection, sometimes we also use IL generator. So that at runtime, we generate some more basically DLLs into memory, which the runtime then compiles into machine executable code. That can be a bit problematic with ahead of time compiled runtimes. So for example, if we ship to iOS, we really shouldn't expect that to be high performant code. So for example, if we run it on the mono runtime on iOS, that actually would be interpreted code. So it would not really be much faster than having some ifs and switches in your code. However, it's still actually surprisingly fast for a lot of use cases. So if you're using things like Xamarin Hot Reload, that is actually making use of this interpreter. And of course, there are custom build steps. So we've had that in .NET framework itself for, I think, forever, for things like generate serialization assemblies, where you click that little button in the project properties, and then you get an additional DLL that has your XML serialization code in there. If you don't do that, that just uses reflection and IL generator by itself. But of course, you could write your own custom build steps. Also .NET, or actually ASP.NET pre.NET 6 had their own custom build steps. If you use tools like protobuf tools, they all ship with NuGet packages that also contain some custom build steps. And another really hardcore stuff is IL weaving. So either you do something to generate C# code to feed to the compiler, or you just let the compiler run and then modify the output of the compiler again. And this is actually very, very difficult to do. Both projects that are listed here are paid, even though Fodi is an open source project. If you end up having any issues with it, they do not accept your issues or pull request unless you actually pay for it, which is good because those things are really difficult to maintain. And that's really only a handful of people who really know what they're doing. And I think you can also ask Gail how they implemented a debugger. So if you modify the generated IL code, then and you want to debug in Visual Studio, what do you do to actually match up to the user code? So lots of crazy things in there. Or you could just go completely crazy and fork the compiler and just change the compiler. So something that also Gail will talk about afterwards. But in C#9, so a year and a half ago, we got source generators. So those are basically compiler plugins that allow you to add code to your C# project. But of course, it's really limited to adding code. So you cannot really overwrite any code. You can't change any code. You can't change any property getters or setters that are auto-implemented by the compiler. But it's really a good point to start. So if you need to change anything after the code has been compiled, or probably IL weaving is good here. So maybe look at Fody or PostSharp. In my opinion, for things like automated iNotify property change, that is probably still one of the better options out there. Even though I'll show you a different example afterwards. But source generators really work directly in the compiler, so you don't need any custom MS build glue logic. There's really not a lot of people who really know what to do in MS build. Also because it's just very hard to debug as well. And you only need a single compiler run. So for example, I was using a source generator, something similar like that before. The problem was it would always run the compiler 2 times. It would load Roslyn, analyze the source code, run my generator, output the source code, and then feed that to the real compiler of .NET. So that was memory intensive and compute intensive and really slow. Now it just works directly in the compiler. And in Roslyn 4, so Visual Studio 2022, there's actually a way to make it faster inside of Visual Studio due to some incremental compilation features. So what the compiler really does is at some point during compilation, it just stops and tells the source generator, hey, here's my current state. Do you have anything to add to that? And then the source generator can add some more input to the compilation, and the compiler would just continue and then generate the assembly. If there are more than one generators, all the generators see the same input. So currently you cannot layer generators, which is sad in my opinion, but it creates some really complex problems that are just hard to solve. And the version that's out there really is basically everything sees the same input, and everyone can contribute to the compilation. If you do want to write your own, there is a very good detailed instructions of all the Roslyn features that you can use and how to pack up your analyzer. There's also some examples. So I've listed 2 GitHub links that list existing source generators. The last one also shows you some usage examples as well. So now that we've had source generators for a while, .NET 6 actually shipped with features that use source generators. And I'll show you some of them now. So perfect. So this is sample application with a JSON file. And the idea is I want to deserialize and serialize the JSON file, which is a very common topic. And again, serialization is this thing where you basically would have to use reflection to look at, okay, what properties are there? What are the types? Then for serialization or deserialization, you might want to pre-generate some code that will be jittered so that serialization is really fast. So in system text JSON, which is the new .NET version of JSON serialization, you would usually call a deserialize function, give it a type that you want to read, and it would do that. And the first time we would call deserialize, it would really have a look at, okay, what properties are there? It would run the reflection code. So that would be a bit slow. However, in .NET 6, we now have a new feature where you can actually use JSON Serializer context to do some code generation. So we have to define a partial class and annotate it with the types that we want to serialize. And what happens then is we can have a look at the dependencies, analyzers, and then we should see the system text JSON source generation analyzer. The reason we see this in analyzers is because source generators basically reuse the same plugin framework that analyzers use. But generators can also emit diagnostics, similar to what analyzers could do. And then we can actually have a look at the generated code. So in here, it would have looked at person. And then we can see there are some interesting things here. So it had a look at the properties. It extracted some of the metadata, so it knows that this property is public, it's a property. And it also implements a static getter and a setter function that does the right access. So no reflection, get property, set property, and so on. It just emits the Lambda function to do that. So we have basically the reflection metadata already generated. And then there's also a serialization handler that has the write null value, write start object, write property, or write string, and so on, which has the serialization calls just in there. So this would really be just generated code. Also, it tries to optimize some of the, where is it? String values. So for example, it also reuses the same pre-encoded strings to just write the UTF-8 representations of JSON encoded text. We can actually customize this a bit as well. So the magic is JSON serializable attribute. I can have multiple of these on the same type, but I could also specify a generation mode where I could tell it, yeah, actually, let me minify that. Yeah, I really only want the metadata, or I just want the serialization. So if you do any deeper customization in the serialization, you might not want to do the pre-generated serialization. If, for example, you do some overriding of the serialization logic yourself, then that would destroy your logic. So, and the way to use that is in deserialize, we no longer need to pass the type, but we can pass our context, access the generated default instance, and select ilist person. And this would then be faster on the first call. For serializing, it's basically the same thing. I can also give it the type information so that it would use the pre-generated serialization code. Let's run that for a second. Yep, still works. So if you want to have faster startup for your API calls, or maybe a bit more throughput with any JSON intensive workloads, that's a very good feature to use. And it's available in .NET 6. Also, since I've previously talked about Razor or ASP.NET Core, so ASP.NET basically has this CS HTML files. And pre.NET 6, there would have been a second compilation step that's in the .NET SDK, actually in the Web SDK or the Razor SDK, that would compile this to C# code, then compile a C# code and put then a view DLL next to your DLL. Or it could, yeah, there were also some ideas with just generating the code and calling the compiler once, but usually having that separate DLL was what the initial version was built for. But now in .NET 6, this is a source generator itself. So I want to show you something different now, because I've showed you how to access that code in Visual Studio. But if you're not working with Visual Studio, so for example, if you're using VS Code or you're not using Windows to develop, there is also a feature that allows you to put the generated code on disk. So in the CS project, you can also say, emit compiler generated files true. And it will then create somewhere in the object directory, it would create a generated folder and then put all the files in. You can also customize that path as well. Let's build that. So, and then you can see all the C# code that the source generator then built. And you can have a look at all the right literal calls and so on. And now this works directly in the compiler invocation that compiles your project. So no more messing around with multiple compilation steps, no longer messing around with additional DLL files that you have to ship with our application. This just works directly as a source generation feature now. So to switch back, feature 2, feature 3 is logging, because logging is something that we all do and that could need an improvement in most cases. So for example, in .NET, we have these log messages. We have the iLogger of Microsoft extensions logging, and then we can pass these named values in here to get structured logging. But if you want to reuse these log calls, you can also use source generators to actually generate these logging invocations. And we can do that both on a class, which makes it look for a logger, or in the logger itself. Let me show you for the class. So for example, if I have a partial class that has an iLogger, I have a partial method that takes 2 arguments and this logger message attribute. In this case, the names here match up. I can specify a level, and I should be able to call that instead. And if I have a look at the generated code, logging generator, logger message. So it extended my model, and you can see the log method is implemented using first is enabled the log level that we're using. How many of you have been using log information, log whatever, without calling is enabled? Yeah, that's something that I usually skip. And so whatever you're doing, this might make it a bit faster if, for example, we're only logging warnings or error informations. And it also created these predefined logging messages. So it calls logger message.define with all of these metadata. If actually we do something a little bit different, and for example, we use last name, first name, it will actually generate a struct in here that holds this information with the toString method that renders the actual string message, so that we have still a structured data on the struct, and then all the logic that makes it a bit more efficient in production. So we have a formatting function, a struct that holds the data, and an actual event, which would be like very difficult to write ourselves. So, but of course, there's also a very practical thing to do. We can also just create an extension method on iLogger. So for example, if something that we could do is things like logging method enter calls, we could just let the compiler generate for us so that we can also call in or create an extension directly on the iLogger interface. Let's have a look. Yeah, here it is. The same as before. So I'm sorry for my voice. Been up our day and still not fully recovered. So again, system text JSON source generator should increase throughput, should reduce the startup time, and there is different versions or different things that you can let it generate. So either basically the reflection part and also the serialization part. You can choose either one or both. The default is both. And there's just some things to look into what you actually need. And even on TechEmpower, this makes the caching benchmark quite fast, which is basically a benchmark that really relies on caching JSON information. So that's a 40% increase, so quite a lot. Of course, when we're doing ASP.NET Core, we can create a context that contains all of the API models that we use. And then we can tell the serialization framework, so we can do add controllers, add MVC, and tell the JSON options to please use that context. And I think you can even add multiple contexts. So you can use it in APIs. And even if you're using HTTP client to call a different API, you can use a context to deserialize things where you actually know which type to expect. So you can make that part fast as well. Again, Razor source generator, it's now the default in .NET 6. You can still opt out if it's causing troubles for you. I haven't had any troubles with that. So go ahead and see if that works. And again, Microsoft Extensions logging source generator should be available by default if you're just using the Microsoft Extensions logging NuGet package. Also, what I didn't show you before, you can also set the event IDs, which is also something that I really don't do all the time. Yeah. And it just makes some things a bit easier. Actually, I can show you some of the production code that I've been recently looking into. So for example, in some project, we use Mediator. And in Mediator, you have basically these request pipelines. And for example, if I just want to have a log message that just logs the event, it's something easy to do. So for example, if I just want to capture event data for debug information, do some APM tracing, that's just boilerplate code that I really want to have as fast as possible. So then writing our own generator. So now we've seen, actually, let me close that. Perfect. So now that we've seen generators in actions, let's build our own. In this case, I've prepared a small demo application, which is the N+1 version of implementing iNotify property changed. So assume we want to be writing a view model. In this case, since we're using a source generator, we can't replace any setters of any properties. So what I've done is we expect an interface that defines which properties we need to implement. And then I want to have an auto notify attribute that doesn't exist yet that tells my source generator, hey, please implement all the properties on that view model with the property changed event. So that when I actually create an instance, camera's gone. So if I create an instance, I can register to a property changed event, and that should fire whenever I change any property. So how would I do that? So the first thing I do is create a library. In this case, it needs to be a .NET Standard 2 library. Nope. No Visual Studio updates before the demo. So it needs to be a .NET Standard 2 library because the compiler is hosted in Visual Studio and in the .NET CLI. So in the CLI, it would be running on .NET Core, but Visual Studio is still based on .NET Framework. So .NET Standard 2 is the best we can get. We can try getting a few more language features in here and enable nullable reference types. But sadly, no .NET 5 and 6 features and so on. We also need the NuGet packages for Roslyn. So Microsoft Code Analysis, in this case, analyzes in C#. Since we may need to publish it as a NuGet package, it's a good idea to set them to private assets all, which means when you publish a code in NuGet, it won't really have any dependency on that and not include that if you publish it somewhere, even on the file system, so it doesn't mess up the dependency hierarchy. Because when you reference the package, you don't actually want to reference any build DLL. So we don't include the output, or we don't include the build result, so the DLL of the analyzer, as referenceable content in the NuGet package. And there's some other magic to use the result as a C# analyzer. And that is actually a one-to-one copy of the generator cookbook that I mentioned earlier. So the Roslyn team will tell you what to write in here, and the idea is that should work. So, and then we need a generator, which is just a class generator. You implement a source generator, and you tell the compiler this should be used as generator, and then you can also specify for which language. So just in this case, I only tested in C#. I'm not really a VB expert, even though I started with VB and VB.NET. But you could also prepare your analyzer to work with Visual Basic as well. Okay, so then the question would be, if we start writing code in here, how do we test it? So if I try to work on a source generator and use it while developing it, Visual Studio would actually not allow me to do that, because the compiler cannot load multiple versions of the same DLL in process. And I think the easiest way, or the most comfortable way, is by using tests. So there is a very, very cool project called Verify, which has a source generators feature as well. So you can write tests that run the generator. The way you do this is you create a C# compilation, run the generator, and then ask Verify, hey, to please verify, how does the thing look? Does the thing change? So the way this works is I create a desired state, and whenever I change something in the generator, Verify would notify me, hey, something changed. Is this still what you intended to do? During the first runs, it probably will not make much sense, especially if you're starting out from zero. But when you build up, it will actually show you the code that's verified. So it will tell me, hey, your source generator generated that. Is that okay? If so, you run a command line command, and it will add that to the verified examples. And then when you change something, you actually have to look, is that what you want to do or not? I will show you that in a bit. So, and of course, the way to do that is we create a C# project with a bit of code and a bit of boilerplate code to just make sure that we have an environment that we can compile this code with. And then we can just use the debugger to create our generator. And we can set breakpoints in here. So that's very comfortable to do. If I actually try to run the tests now, they should fail. Yep, both failed. Okay, then let's have a look at the generator. So again, we need to implement iSource generator, which gives us two methods. One is an initialization method, where the compiler basically gives us a chance to initialize, have a look at the compiler configuration, also register things that for any callbacks that we want. And then there's an execute function, which basically tells us, hey, this is the state of our program. Do you have anything to add? So this is the point where we can actually run the code that adds to the compilation. And to do that, the first thing we can actually do is this attribute. So where would I put something that would contain this attribute? So I could create another project with a DLL that is then somehow trimmed out of the published output, or I could I could cheat and just add it as a source. I am a source generator. I can actually emit that attribute. So I can do something in the initialize method. Say after you've finished initializing, I can already add some source code in here. So I can tell it, please add the auto-generate attribute C# file with that content. Since that doesn't rely on any program state, I can do that directly during initialization. So we have the attribute in here. And then what I want to do is I want to have a look for the things that I need to generate. So I need something to keep track of that. So I would use a record, but since we're using that standard 2, I cannot use record, so it's a class. And the way this is Roslyn has basically 2 sets of APIs that you would work with. One is a syntactic context, where you basically look at the syntax. So names, brackets, spaces, keywords, and then there is a semantic interface, which is basically the next step. After the compilers parse the syntax, it would have a look at the semantic meaning of things. So if I write a type name somewhere, it would actually try to resolve, okay, what do I mean when I write this attribute name, for example? And those are then symbols. And I want to keep track of the semantic information that I need to generate. So I'm looking for types and the interfaces that I need to implement for them. So this means I'm looking for person view model and the interface or multiple interfaces that I need to generate for. And to do that, I can actually use a syntax receiver. So this is a pattern where the C# compiler would just go through the syntax tree. This is called a visitor pattern. And on every node that it encounters, it would call us and tell us, hey, do you want to do anything with that node? And this also uses the most direct or the fastest way to traverse the syntax tree, instead of us just doing things like, for example, link queries on all the nodes, which would be quite slow. So that's the part that will track the things that we need to generate. So, and since that's just a class, I can actually set that up. So during initialization, I can tell the compiler, hey, please traverse all syntax node and use this receiver as our callback so that we can keep track of the things that we need to generate. So, speaking of syntax, a good way to visualize what we're doing would be tools like SharpLab, where we can just paste code and ask it to compile. In this case, it doesn't compile, but this has a syntax tree feature. Perfect. That will show us how the compiler sees the code. So we can have a look at the basically compilation unit, which is the file. It lists all the statements, all the expressions. So we have a class declaration, attribute list, attributes. We see that there are name identifiers and so on. So you will see these words also in the Roslyn API. So that we can, when we get these callback invocations, we can just filter out for the things that interest us. So we are only interested in class declaration syntax, and only if they actually have attributes on them. And then when we found classes that interest us, we can switch from the syntactic or this from the syntax model to the semantic model. So we can ask the semantic model, please tell me what this thing actually means. And we can get a type symbol. So everything that is called symbol has semantic information as well. And then we can filter a bit more and then make sure, is this actually the attribute that we generated? So again, if you would just see auto notify as a syntax element, we would have no idea if that's actually the thing that came from that namespace. So that is semantic information that we need here. And we also don't want to look at things that aren't fully implemented yet. So for example, if we didn't pass any constructor arguments to that attribute. And then we just keep track of the things that we need to generate. So then there is some boilerplate function that I created that just takes one of these things that we keep track of, the implementation to generate, and just creates a string for the code that I want to add. So I usually start with auto-generated so that it doesn't trigger any code analysis warnings, especially if you use that feature that writes it to disk and you have any tool that looks at all the CS files on disk to check for any code style violations. So just to make sure nothing trips your CI. Also, some projects may have nullable reference types enabled, some may not. So make sure you cater to all the project configurations that you support. So we might have a namespace, we might not have. And then we can actually go to creating the code. So we can declare that event, property change event handler. We can loop through all the interfaces, then through all the properties, emit a field that holds the value, emit the actual property, and then return the string. So that's a very naive implementation. And then in the execute method, we would just need to call this. So we can get some more information about the project, get back our syntax receiver that has kept track of all the things that we need to generate, and then create these implementation strings and add them using the context add source, add them to the compilation. So let's check if my tests work. Perfect. So how do we use that? We can actually do that using add project reference. Then do some magic in the project file. In this case, we can tell it that we don't want to have this as basically a logical code reference. And we want to use the generated DLL files as analyzer so that the compiler sees them. And now Visual Studio should have loaded the DLL, run it perfectly, dependencies, analyzers, notify property changed. Perfect. We generated the attribute, we generated the view model. So let's try to run that. Hello world, and we got the property change events. So now going back to the tests that I mentioned earlier, if I then decided to change something, for example, I want to use expression bodied members. The way these verify tests work, if I run them again, it will actually show me the difference. So it runs this unit test project that I configured. Since I haven't written any code assertions that basically ask how this code is formatted, I did it in a way that asks the human, is this correct? Is this what you wanted? So I have to decide if that was a conscious change or if it was a mistake. In this case, it was a conscious change. And it also showed me in the test output, hey, if that is what I wanted, it should be, it's probably the output. Will basically at some point show me a verified command paste in clipboard. So it will create a command, basically moving some file received to verified. So it can actually verify the change. What this does behind the scenes, it will update this file here that contains the verified example. And then in the future, if I run the test again, it will pass. But it also means I will have to commit that example to source control as well. So it's an easy way to do some at least basic smoke testing of your generators. Okay, then next thing would be doing the same, but faster. And that's, there are new APIs in Roslyn 4 now. So I've showed you the iSource generator, which is supported in Visual Studio 2019. It still works in Visual Studio 2022. But there is a new version of these APIs now. So I can do basically the same thing, but use Incremental Generator. This now only has one method, and it's just an initialize method. The difference is I no longer have these explicit extension points where I have to do something. It's a bit different that it provides me the things that are in the project or in the compiler. And I can then create a logical tree of things to do in order to reach my desired output. So, for example, there is now a syntax provider, which is the type is Incremental Generator something. And this is actually not a static value, but it basically provides me a stream of updates for the things that are in the project. So think of it as an IEnumerable or a reactive stream, where I can basically use operators to work with these streams. So I can create a syntax provider that has a filter, use a special comparer, and then do things that really look like link statements, but this where is, let's try downloading. This where is actually implemented for incremental value providers specifically to get sources. It looks just like link statements, but it's a very special implementation for Roslyn. And the idea is that at any point of these trees that are built here, the compiler would keep track if anything has changed in that step. So for example, the syntax provider would be called for every syntax in the project. But for example, if only one file changed, then this lambda might only be called once. And this is actually nearly the same code that I've used before, just now in something that looks like link. Also, the select statement that generates my code calls this generate implementation. Maybe if only one of these implementation to generate instances changes, then this also might be called for just the one generated file that actually needs to be changed. So this is a new API in Roslyn 4. I'm not sure what the implementation status is. So in version 17.0 of Visual Studio 2022, this was still run every time completely. But over the last versions, they should have started to enable these incremental features. Of course, the problem is whenever you're using custom classes, you also need an equality comparer to use. So we can use this with comparer and so on if you're not using any of the standard types. And the idea is that when you type in the IDE in Visual Studio, it would not run the generator over all the code in your project, just on the files that change, and ideally only for the parts of the file that are actually relevant to the generator. so that you don't have too much resource usage, even if you have a lot of generators. So that's on that. There are some other things you can use. So I've mentioned schemas and OpenAPI specifications and so on. You can actually make any file in a project also visible to the compiler and therefore visible to the source generator. So if you set this build action to C# analyze additional file, or in this year's project would just be additional file, then you can ask this generator context, hey, give me all the additional files, maybe that end with a custom suffix that is specific to your generator. You can also add metadata on this. So for example, if I have that schema JSON file, I could add some completely arbitrary metadata, in this case, generated models namespace. If I want to set any input from a generator, then I also need to compile that this metadata has to be visible for the compiler. So it just collects it as well. And then I can write an analyzer that also tries to get that value for that file. So in this case, if I have a serialization format generator for a special schema, then it would know the namespace that I configured for that file. There's even some extension method for Visual Studio where you can ship some example files using NuGet packages so that these metadata then also pop up in the properties dialog of the file, which is, for example, something that the protobuf tools do. So you can basically select, hey, generate server or client. That's using the same thing behind the scenes. You can do something similar with project properties. So again, MS Build is very, very open, very customizable. So wherever you are in the project, you can define a property group and you can create arbitrary properties. And then in an item, you can tell the compiler, and again, this is something that the compiler looks for. Yeah, I want that project property to be visible to the compiler as well. The way you would do it for a generator is you would ship that item group as some part of your NuGet package. And then that property group could be in a consuming project. And then you could query the global options of the analyzer and read that project property. Yeah, some other things to do if you do decide to ship your generator. Again, make sure that you support nullability if it's turned off or on. Otherwise, you would confuse the users. Also, make sure that you have some understanding of which language version is used. So if you do emit code that has some newer C# features, that might not work if, for example, a project is configured to use a lower language version. Do note that the language versions can be set even for current projects to quite old versions. So maybe just something to look out for. Also, if your users are not using your analyzer or your generator correctly, you can do the same things as analyzers can do. You can emit diagnostics. So you can actually emit a warning that then shows up as a squiggly in Visual Studio or VS Code and tell the user, hey, did you mean this? And I think you can even generate fixes. And again, make sure your generator uses one of these configuration options if you need any configuration. And if you use these new Roslyn 4 APIs, just make sure that you communicate that your generator only works in Visual Studio 2022 and up. Yeah, most people, sadly, don't switch overnight to the latest Visual Studio version. And if you want to pack it as a NuGet package, just follow the instructions on that cookbook, and it will give you all the MS Build magic to do.